Algebra 2 trig pre-college, evaluating functions. If f of x equals x over x squared minus 16, what is the value of f of negative 10? And a good way to think about functions is this notation of f. Now this equation here, it's basically f of x is like y equals, but I'm calling this equation f. And f of x, think of it as f of input. And so what's in these parentheses, I'm going to input into the function. So instead of f of x, it's f of negative 10. So notice that I have f of x here, and I have x's in the equation. Well, when I change it to f of negative 10, I'm going to replace my x's with negative 10s. So f of 10 is going to be negative 10 over, x is in the numerator, so now it's negative 10 here, x squared, which will be negative 10 squared. And make sure if you're inputting a value into something that has a constant, a coefficient, or an exponent, you're using parentheses, minus 16. So this would simplify down to be negative 10 over, now negative 10 squared is positive 100 minus 16. Remember, a negative number squared is positive, and 100 minus 16 is 84, and this will reduce to negative 5 over 42. If f of x is x squared minus 3, then what is f of a minus b? Again, this is simply my input. And all these x's are placeholders for your input. So whatever I put in, I'm putting in the x spot. So if I'm going to put in an expression, it's going to go here, squared minus 3. See, f of x equals x minus 3 just means f of your input, whatever you put in, is going to be your input squared minus 3. So f of a minus b is going to be a minus b squared minus 3. Right? X just stands for input. A minus b squared is a binomial squared. We see it all the time. It's a minus b times a minus b. It's FOIL. You can't just square the pieces inside because it's a polynomial. You'd have to do the whole distribution process. But it's going to come out to be a squared minus 2ab plus b squared. So you'd have a squared, you'd have a negative ab, another negative ab, which would combine to be negative 2ab plus b squared minus 3. And there's no like terms after this to combine, and so that's our final answer, and that's why the answer is C. But yeah, you could plug in numbers like negative 10, or you could plug in expressions like a minus b. If f of x is 3x and g of x is 7x minus 1, what is f of g of 4? So this is a composition function where we have two functions, and we're going to do them one at a time. This little bubble symbol means you actually go right to left, which is different than how we do most things. Like we tend to read and write left to right. Well, this time you're going right to left, so that means you're going to do g of 4 first. This could also be written as f of g of 4, and sometimes you see it written like that. But you do to the right of the bubble first. So g of 4. What is g of 4? Well, g of x, g of my input, is 7 times whatever your input is minus 1. So that's 7 times 4 minus 1. 28 minus 1 is 27. And now I'm going to take that value and plug that into f, into my second function. And so that would be f of 27. And the rule for f of x, whatever I'm doing my input, it's 3 times x. It's 3 times my input. So 3 times 27. Just going to get my calculator out because I don't want to make mistakes in my video and do mental math. 3 times 27 is 81. Well, obviously, I guess that's just a power of 3. So the answer is 81. The final answer is 81. 27 isn't one of our answers. It's just kind of part of our answer to get there. Here's another composite, but this time there's not a number here. It's x. And so f of g of f of x. So when you work your way in here, plugging x into f of x, well, that's this. X is already plugged into f of x. You get an expression. So then we want g of that. So g of f of x is g of x squared minus 5, because f of x is x squared minus 5. And so you have to be a little careful here. These are a little tricky when you're plugging kind of an expression into an expression. And then what are we doing for g in this function? G of our input, g of x, is 6 times x. It's 6 times our input. So this is going to be 6 times x squared minus 5, which is 6x squared minus 30. The answer is B. The last thing we need to do with functions is this symbol here, f. It looks like a -1 exponent, but it's not. It's actually the symbol for inverse. And it would be read as f inverse of x. So you'd be given a function like f of x, and then we'll say, what's f inverse of x? And inverse on a coordinate plane and everything like that basically means coordinates like x, y switch to become yx. So like if you had the point 3, -1, the inverse of that coordinate would be -1, 3. And so inverse means switch x and y. And that's exactly what we need to do here. But f of x equals x squared minus 6 has no y. But as I said earlier, remember that f of x is the same thing as y equals. So you could just think of this as y equals x squared minus 6. And then to take the inverse of this equation, I'm going to switch x and y to make it x equals y squared minus 6. And now I'm trying to solve for y, because we always like our equations to be y equals. So I'm going to add 6 to both sides, make it x plus 6 equals y squared. And then I don't want y squared, I want just y. So I'm going to have to do the square root of both sides to get that to be just y. And I end up with y equals the square root of x plus 6. And that's your inverse equation, but we're going to write it in inverse notation. Instead of y equals, we're going to replace it again with the f inverse of x equals the square root of x plus 6. So to do inverse, you basically want to think of your y, f of x as y equals, like we did here, switch your x and y values, and then solve your equation for y, and then replace your y back with your function notation here. And you can really see an inverse relationship between these two equations. This one is being squared, this one's being square root. This one's got a minus 6, this one's got a plus 6. And so basically every operation is the inverse of these two things. And not only that, if you were to do f of, f inverse of x, like I was talking about before, plug one function into the other. Like say we take this and plug it into this function, where we're going to square it in minus 6, it'd be the square root of x plus 6 squared minus 6. And this is plugging f inverse into f. Well, what happens when you square a square root? Radical disappears. It's just x plus 6 minus 6 is x. And it'd be the same thing if I were to plug this into here. The whole point with a function and its inverse is if you plug those equations into each other, they cancel each other out because it's all inverse operations, and you're always going to be just left with x. All right, so we'll practice some input with composite functions. We'll do some inverse functions and things like that tomorrow in class. All right, bye.